Oh iya, oke, siap. Prof. Ismail?
Ya.
Ya, Pak Agus, mungkin.
Ya. Cek.
Cek.
Ladies and gentlemen, welcome to the 6th International Conference on Informatics and Computing ICIC 2021. This event will be guided by two amazingly breathtaking Masters of Ceremony. Now let's raise a toast for Mr. Agus Priyadi MPD and Ms. Reti Palupi MECOM.
Hello, good afternoon, ladies and gentlemen. Welcome back to the online conference 6 ICIC 2021. And we are now about to begin our next agenda for the second keynote speakers. For the next plenary lecture, now let us welcome our second honorable keynote speaker, Professor Ismail Khalil, PhD, from Deputy Head of the Institute of Telecooperation Johannes Kepler, University Linz in Austria. This plenary lecture lasts for 60 minutes and will be followed by Q&A session. Before the speech, let us visualize his profile video.
Professor Ismail Khalil PhD is holding a tenure position as a senior researcher and lecturer at the Institute of Telecooperation Johannes Kepler University Linz in Austria. He currently teaches, consults, and conducts research in mobile, multimedia applications and services, agent technologies, and information integration. He is also interested in the broader business, social, and policy implications associated with the emerging web technologies. He has completed his studies at several leading universities as follows: Bachelor of Science in Electrical Engineering and Education, University of Technology, Baghdad, Iraq, 1985. Master of Science in Computer Engineering and Information Systems, Department of Electrical Engineering, Gajah Mada University, Yogyakarta, Indonesia, 1998. And PhD degree cum laude predicate in Computer Engineering and Information Systems, Department of Electrical Engineering, Gajah Mada University, Yogyakarta, Indonesia, 2001. Apart from being a researcher and lecturer, he is also an editorial in several leading journals, such as Editor-in-Chief of the International Journal of Web Information Systems, or JWIS, Editor-in-Chief of the Journal of Mobile Multimedia, or JMM, Editor-in-Chief of the International Journal of Mobile Computing and Multimedia, or IJMCMC. Let us welcome our today's keynote speaker, Professor Ismail Khalil, PhD.
Okay, Prof, please, time is yours. Yes. You are still mute, Prof? Sorry. Your voice is not clear here, Prof.
Okay.
Yes.
Now
Yes,
you
clear.
can hear me. Okay.
Please.
Thank you very much for the, yes. Thank you very much for inviting me to this interesting conference. I would like to thank APTIKOM and also by Yusuf, by Hosni for giving me the opportunity to talk in this conference. How can I share my screen? Can you see my screen?
Yes. Yes, excellent.
But
It's clear.
I cannot make it full. I cannot make the screen share full screen.
If anyone using,
Maybe you can
should,
click the play button, Prof. Play button above.
yes, but
Play.
the host need to give me the permission to share the full screen. Can you see full screen now?
no,
No.
not full screen. You cannot see the full. Maybe you may share all screen, Prof. Maybe
Sorry.
you. I think you have to share all screen.
Yes. Now.
Okay. Excellent.
Okay.
Okay. So
Yeah.
thank you very much for the opportunity to talk in this interesting conference. I would like to thank APTIKOM. I would like to thank Yusuf, Hosni for giving me this opportunity. Actually, I mean, as you know all, that artificial intelligence is all the rage. Everybody is talking about artificial intelligence. And when you do a simple Google of the term artificial intelligence, you will see millions of results. Some of them are serious and useful. Some of them are nonsense. And some of them are written by people who are specialized in the field. Some of them are written by journalists and other amateur people. And also, artificial intelligence invaded all aspects of our lives. Everywhere you go in movies, you will find movies about artificial intelligence, a lot of novels and stories about science fiction and the possible uses of artificial intelligence, and everything nowadays is labeled as smart. So whatever you use in your life, your phone is called a smartphone. Your washing machine is called a smart washing machine. Your refrigerator is called a smart refrigerator. We always try to give this field of science some kind of human characteristics. So most of the time, we try to anthropomorphize the concept of artificial intelligence. And sometimes we try to sensationalize the term of artificial intelligence. And in some extreme cases, we try to even emotionalize the term of artificial intelligence. Since I was a kid, I was fascinated by the concept of intelligence. I tried very hard during my young years to agree on a definition of intelligence. What is intelligence? And how this intelligence can be implemented. And talking about the human case of intelligence, how we can upgrade our intelligence. And what are the goals of intelligence? Why do I need to upgrade my level or skills in order to be called an intelligent person? And fast forward, when I become a computer scientist and started working on concepts relating to intelligence, starting with my PhD thesis on the intelligent integration of information, which was, one of the earlier steps in what we call nowadays web intelligence. Till when I started at the University of Utrecht, I was working at the group called Intelligence Systems Group. We were working on agent technologies and the use of agent technologies in everyday life. Then I moved to the University of Linz and I started to work on mobile computing and what you call nowadays smart technology, smartphone, smart TV, smart whatever technology. But till today, I couldn't find a clear and appropriate definition of the term intelligence in order to be able to define the term artificial intelligence. Because as you know, artificial means human made. So it is an intelligence which is made by a human. And so I started to change the way I think about the concept of intelligence and the concept of artificial intelligence. So I tried using the available technologies in front of me as a computer scientist working in the field of artificial intelligence to use artificial intelligence as a rational model for understanding the human brain. So starting with the definition of intelligence, it may help me to understand my own intelligence as a human. So this is what I am going to share with you today. What is artificial intelligence? What are the technologies that can be used to implement artificial intelligence? And why do we need artificial intelligence in order to understand our own intelligence and how to upgrade our intelligence and the goals we want to achieve when we become intelligent? So I will start with a brief discussion or introduction to the concepts of intelligence and artificial intelligence. I will talk about the different types of intelligences and how these different types of intelligences can be implemented in computer science. Then I will talk about the artificial intelligence ecosystem, understanding how artificial intelligence work is a very important step in understanding how our brains work. Then I will talk about the components of artificial intelligence, the sensing, the reasoning, and the acting component of human intelligence and artificial intelligence at the same time. I will talk about the role of big data in the advances of artificial intelligence we are seeing nowadays. And then I will try to conclude with the answer to the question which I just started with, how artificial intelligence can help us understand our own intelligence, and to share my view on the future of artificial intelligence. So let us start with the definition of intelligence, human intelligence. As I mentioned, I read 100 books, 100 papers. I read many websites to come up with a clear and fine-cut definition of the term intelligence, and I couldn't find anyone. So what I put in front of you is the dictionary definition of intelligence. So if you open any dictionary, even in Bahasa Indonesia, you will see that intelligence is defined as the ability to acquire and apply knowledge and skills, which means that intelligence involves some kind of mental activities. On top of these mental abilities is our ability to obtain a new information, which we call learning. The second activity is reasoning, thinking, how to process the information that you have learned in the first step, and to try to come up with results of the processing of this information you have learned in the first step. Then you need to determine the validity of the information and search for a relationship between the different pieces of the information in order to be able to connect the dots and to be able to conclude something. And then we consider the meaning or the sense of the information we have processed. And based on all these different mental activities, we start acting, whether it is problem solving, whether it is decision making, whether it is any kind of activity which is related to intelligence. And this can be applied to different types of intelligence. There are people who never entered a school, but they are very intelligent, for example, in drawing or in playing music or in some other type of mental activities. But the process of how we become intelligent is the same for every type of intelligence, regardless of the background, regardless of the ethnicity, regardless of all the normal attributes we attribute to a human being. So I found the theory of multiple intelligence of Howard Gardner is the best way to look at intelligence. There is no one single type of intelligence. There are different types of intelligence. And then at the end of the talk, I will tell you how these different types of intelligences are implemented using what we call nowadays artificial intelligence. How computers can simulate these different types of intelligence. So according to Gardner, there are 8 types of intelligence. One of them, as we always consider the best way to say that somebody is intelligent, is their ability to reason, to think logically, and to handle mathematical problems. Einstein is considered the most intelligent person on earth because of this ability, his logical mathematical intelligence. But for example, his interpersonal intelligence was the lowest among all the people. He couldn't succeed with his wife, he couldn't succeed with his children, he couldn't succeed in his social life. There are also the visual spatial intelligence, which is the ability to create visual images and think in a three-dimensional space. There is a kind of intelligence which is owned by athletics and sport people, which is called the bodily intelligence. And there are the musical intelligence, there are the intrapersonal intelligence, our ability to understand ourselves and our thoughts, our feelings, which is called nowadays social intelligence. And we have, for example, the naturalistic intelligence, which is how to understand the nature, how to see patterns in the nature, and how to work in nature. So this means if we apply the multiple intelligences theory to anybody, anywhere, this means that any person on earth is intelligence on his or her own terms. Now let us look at how to define. So you notice that it is very difficult to define the term intelligence. So how to define the term artificial intelligence? Artificial means a human-made. So the base definition I can use in order to define the term artificial intelligence is to say that it is a subfield of computer science. Sorry, 3, do you have a question?
Proceed, Prof.
Okay, so artificial intelligence is a subfield of computer science aimed at the development of computers capable of doing things that require intelligence, regardless of what is intelligence, when done by people, which means, according to the definition I presented in the last slide, it is thinking. Sorry?
Proceed, Prof.
Okay, thinking and acting intelligently. So, I mean, as you can see, artificial intelligence started in 1958, and the term was coined at the Dartmouth conference, where the top 8 minds in artificial intelligence said that any program is considered an artificial intelligence system if it does something that we as a human think of as intelligence. This means that all the system which has been labeled as artificial intelligence are not intelligence, because the things that we have seen so far are normal in our daily life. For example, solving mathematical problems. For example, fraud detection. For example, trying to figure whether the image is an image of a cat or a dog. To understand language. We don't consider any one of these systems which are developed nowadays to be intelligence according to the definition of the people who participated in the first conference where the term of artificial intelligence has been coined. Now, what are then all this, or what is all this buzz around artificial intelligence? All this noise around artificial intelligence nowadays is due to the core advances in the technologies which drove the advances in artificial intelligence. On the top, we have an increased computational resources. I mean, a simple smartphone has the capability of the best mainframe 10 or 20 years ago. The smallest notebook nowadays have the capacities and the computational resources which were not available in the most sophisticated supercomputer 10 years ago. The second driver of this interest in artificial intelligence is the explosive growth of data. We nowadays leave a huge exhaust of data behind us. And in this data, we live every day, whether communicating by email, whether doing WhatsApp, whether writing on the web, whether organizing conferences, whether having a virtual conference like this, we always leave behind us a huge amount of data. And this data, if it is used successfully, it will be a source of business for many companies who are looking at what we leave behind us and how they can use it in order to benefit from it. The third, which I consider the most important factor in the success of artificial intelligence, is the move from thinking that artificial intelligence is the solution to all human problems to focus on some specific problems and trying to solve these specific problems using artificial intelligence. And then the shift from knowledge engineering to learning. I am old enough to work on expert systems, and it was a nightmare. I mean, one of the things I tried to develop for my PhD thesis was an expert system for search terms. And it was a nightmare to design this rule-based system. Nowadays, everything is left to machine learning, so you don't need to design the knowledge base yourself. You need to define the rules, train your algorithm, and the algorithm will figure on its own how to derive new rules out of the rules which has been taught to the machine. And the way we reason about the machine. So machines don't have to reason like people to be smart, which is the same thing. Planes don't need to be birds in order to be able to fly. So we tried to separate the concept of artificial intelligence as related to computers from the concept of intelligence as related to a human being. And of course, in order to understand what I meant by saying that we shift from a broad artificial intelligence to systems that can solve specific problems, we need to just go through the different types of artificial intelligence in order to make the picture clear to you, and so I can proceed with what I have wanted to say today. So there are two types of artificial intelligence. The first type is called the strong artificial intelligence, where people are trying to simulate the human intelligence. So it is a kind of a clone of the human brain in a computer system, which means that we try to build systems that act and or think intelligently like human beings, which is a very imaginary, if not impossible, goal of the systems we have nowadays. The second, which is the more useful way of looking at artificial intelligence, is what's called the weak artificial intelligence, which is concerned about the building of systems that do the right thing. So, for example, IBM Deep Blue plays chess better than the human, but it can tell us nothing about how a human thinks. Deep Blue implement a very sophisticated set of rules in order to be able to win the chess game. But how we play chess is totally different from the way how Deep Blue played chess with the world champion. And this gives us the possibility to design and implement systems which fall between the concept of strong artificial intelligence, where we try to build systems that can simulate the human intelligence, and the weak artificial intelligence, which is building systems that do the right things. So what I thought about is, how can we use our human reasoning model as a model to help the computers do the same thing, or what is called in the literature a rational model. Let me just, before I dive deep into this concept, tell you how this worked. There was an experiment. I mean, Google is the most intelligent search algorithm on earth. Okay, I mean, sometimes Google will be able to figure out what you think about before you start thinking about it. You start typing some query, and the result will appear in front of you in a minute, in a second. And the results are always what you are looking for. So a group of scientists tried to see whether Google is a rational model of how we as a human think. So they started to simulate the PageRank algorithm of Google on a human. So they asked the person, for example, what is the best, and they asked them to guess what is the rest of the sentence. And they discovered that 80% of what a human can predict of the query is exactly what Google is doing. So they concluded that Google or PageRank algorithm is a kind of rational model that can be used in order to understand the way we as a human think. So, for example, the cup is on, you guess it, on the table. The same way, if you write in the Google search, the cup is on, Google will be able to predict that the next term, which will be written, is table, and will save your time. Then we have what is called the narrow artificial intelligence, which means that we design the system around a specific task. So, for example, fraud detection, we design the system in order to prevent a fraud. This system will not be able to generalize to other problems. Its job is to detect, or, for example, to predict the stock market. So the system is designed in order to predict the stock market. It's not designed to solve the problem of, for example, search or whatever other problem. The second is called the general artificial intelligence, or the broad artificial intelligence, which is designed around the ability to reason in general. Some success has been achieved in the field of deep learning, building systems which are considered to be broad artificial intelligence. The problem here that most people don't think of narrow artificial intelligence as intelligence, or as the father of artificial intelligence, John McCarthy, said, as soon as it works, no one calls it artificial intelligence anymore. Okay, I give you an example. A smart switch is smart. If we define the smart switch in the sense how we define artificial intelligence, it works like a human will. Okay, when the temperature is high, then the heating system is down. If the temperature is low, then the heating system is turned up. So it works exactly the same way. But since we know the engineering behind how the smart switch works, we don't consider the smart switch as artificial intelligence anymore. And this applies to whatever. I mean, including Google, for example, which is, as I mentioned, the smartest search engine on earth. As soon as you understand the PageRank and you go into the details of the PageRank, the algorithm behind the search of Google, then you don't consider Google as an intelligent search engine. So as soon as it works, nobody will call it artificial intelligence. And this is the reason why, when you look at the literature, and this is something that I wanted to share with you, people try to avoid the term artificial intelligence, including, for example, at our university. We don't have a department. We have at the Faculty of Computer Science, we have 11 institutes, and almost 6 of them are related to artificial intelligence, but no one of them is called artificial intelligence. Some of them are called cognitive computing, smart machines, intelligent assistance, predictive analytics, recommendation system, deep learning, machine learning, etc., etc., etc. Because the term artificial intelligence doesn't reflect exactly the objectives of why it is artificially intelligent. So we try to define it in a more narrow way, so people will not say this is a narrow artificial intelligence, this is not a general artificial intelligence, and this is the reason why you are not doing artificial intelligence. Okay, so let us go back to our human way of becoming or of thinking and acting in an intelligent way. So the first thing we do is to look at our environment, to look around us, to listen to signals from the environment. And the next step, we try to learn, whether in the classical way of learning, by attending schools, by reading books, by listening to the elders, etc., etc., etc. And then, based on what we have seen and what we have listened to, we try to connect the dots. We try to derive meaning out of what we have seen and what we have learned. And based on this connection between the different disparate dots we have connected now, we try to predict. Prediction doesn't mean forecasting the future, but means predicting what to do next, whether to solve a problem, whether to take a decision, whether to act on something. And based on the results of what we have predicted, we try to correct our course. So if we made mistakes in a decision last year, most of the time, we are not supposed to repeat it in the future. And then we repeat the cycle. We look, listen, learn, connect, predict, and correct. And this cycle of the way how we human think and act can also be implemented in the artificial intelligence system. So the first step is to the step of sensing. Okay, so taking the sensor data about the world, which we capture as a human with our eyes, with our ears, with our five senses, and which can be captured by computers in different ways. For example, image processing is the way how computer sense the world and recognize important objects, important paths, important faces, etc., etc. Speech recognition is another way how computers can sense the world around them to filter out the noise and recognize the spoken words. And there are different senses, actually, and this is what I am going to talk about at the end of this talk. Our human five senses are augmented by tens of other senses available on our devices, whether it is the mobile device, whether it is our own computer, whether it is the search engine, etc., etc. The second step is the step of reason and thinking about how things relate to what is known. So this also can be implemented by computer systems through, for example, language processing, how to convert words into ideas, situation assessment, how these ideas can represent a specific situation, logic-based inference, which is based on the truth value of the ideas we have processed in the first step, event-based inference based on the weight or the evidence of the truth we have derived in the previous step, and then the acting part, the planning, the problem solving, what to do in order to achieve the goals delegated by ourselves as a human to our computer system. And then the learning process, which is the building of new knowledge and also the new language generation. I am not talking about natural language processing. I am talking about natural language generation, which is still a faraway objective of computer systems. Computers cannot, for example, write an essay about a topic you have suggested to them. And the last part is the acting part, okay? And actually it is beyond the scope of artificial intelligence. It is more related to engineering, speech generation, robotics, mechatronics, etc., etc., etc. Now, how this can be applied to the way we think as humans? So the look is what Google is doing. Google looks at a huge amount of web pages. I tried to figure out how many web pages are available for Google. So I tried to actually query the term they, because they is almost in every web page written in the English language. So the Google returned almost 20 billion results for the keyword they. I assumed that the number of non-English pages is equivalent to the number of the English pages. So I multiplied the number by 2 and I reached the conclusion, which is not, I mean, accurate 100%, that there are almost 40 billion pages available on the web. I'm talking about the service web. I'm not talking about the deep web. So the looking is the eyes of Google. The listening is what machine learning is doing and what Google is doing in order to present the results to us. The learning part is the information retrieval, which is again part of the APTIKOM conference. And then how to find useful information out of what we have learned is using logic and reasoning. And then the prediction part is the data mining part, and the correction part is the optimization part. So this is how artificial intelligence try to apply the way how we think in order to make the system more intelligent. Now, what is the role of big data? So big data, or depending on the amount of data available to the machine learning algorithm, we can improve the performance. So if the data available to the algorithm or the model is small, then the model will perform low. If we increase the amount of data, the performance of the system will be increased exponentially. And we have actually applied this. I am working with a student who is working on attention recognition, and we tried with the algorithm we using with 1,000 sets. The result was very unrecognizable. Then we tried to increase the number of samples to almost 100,000 samples. The algorithm performed very well. So the performance of, or the availability of big data will improve the performance of the algorithm, will not change the output of the algorithm. The algorithm will work whether you give it 10 samples or 100 samples. The only thing that will be improved is the performance of the algorithm. And just to summarize, that artificial intelligence use the three major components of a human reasoning, which is assessing, looking at the word, inferring, drawing conclusion, connecting the dots, and predicting, making guesses about what is next. So, and this is what, I mean, I just gave you an example or two examples of recommendation systems. It is reported, as you can see in front of you, that 35% of Amazon revenue are generated by its recommendation engine. All the recommendation engine is doing is to look at you, me, and the others, try to put us in groups, and then they predict what we are supposed to buy next. The same thing applies to, for example, Netflix. 70% or 75% of users select movies based on Netflix recommendations. I don't remember I select the movie by myself. Most of the time, I select the movie based on what Netflix suggests. And again, what Netflix is doing is to look at me, look at you, look at the others, infer what are our interests, and then predict what we are going to watch next. And so let us go through these three steps used by artificial intelligence algorithms in order to provide us with accurate results that can be considered as intelligence when done by a human, which is the objective of this talk. The second part is the inferring part, which is to find the relationship between things. And this can be done by similarity check. The books you bought, part of them I bought then the books which I didn't buy may be of interest to me, and I don't know about it. So this is how similitude check works. Categorization, if we try to categorize the users in groups, so these people are interested in cookbooks, these people are interested in books which are related to computer science, then we can target what we try to sell to them. And the evidence, if they will buy the book recommended to them, then it is an evidence that what we have or our algorithm works fine. And this is an example, for example, about the predicting part. So making guesses about what is going to happen next by calculating the similarity. So here are two examples, actually. Here in this example, we use user-based filtering. So we categorize the people into groups, and based on this categorization, we try to recommend products to each one of them. The second is an item-based filtering, where we can group different items together in order to recommend them to different users. So here, for example, most people who bought grapes bought watermelon. This means that if the person will buy, for example, only grapes, then we can suggest watermelon to them. And in order to now to build this rational model, or how can we use artificial intelligence in order to understand the way we think, I am going to go through three examples. How much time do we still have, Yusuf?
MC. Halo, Pak Agus.
I think. So I will go through these three examples in order to explain to you how can we use artificial intelligence to understand the way human think. I will take the example of IBM Watson. If you read the abstract of my talk, I mentioned IBM Watson. IBM Watson is the first computer that passed Turing test. No computer before Watson passed Turing test. And you understand Turing test. You human need to differentiate between another human and a machine. And Watson was the first computer who passed the Turing test. So what is Watson? Watson is an evidence-based engine. It starts with a question, for example, a list of symptoms or a list of financial goals. It needs to provide an answer. Starting with the set of symptoms, it needs to come up with a diagnosis. Starting with financial goals, it will come up with some advice on how to reach these financial goals. So this is done by building an argument for the truth of the competing response. The amount of information available to Watson is huge. So there are thousands of rules will be fired at the same time that map the information needs on the buttons of the answers in the text. And each rule will be assigned a weight. Rules with a higher weight will overcome the rules with a lower weight. So the rule with the same answer can reinforce each other, while the rules with different answer will compete with each other. And at the end, all these answers or the answers with the best overall value will come to the top and will be chosen by Watson. Now assume that instead of, the human who competed with Watson, we replace them with some computerized voice. And Watson uses also computerized voice and asks you to judge who is the human and who is the machine. You will definitely choose Watson to be the human and the other two competitors to be machines, which means that Watson provide us with a glimpse. I'm not saying it is something true 100% on how we as a human think. This is Watson uses some sophisticated natural language processing technologies to understand the language. Google read what you write, but it doesn't understand if you have a flu or you have COVID-19 and you are looking for some kind of common systems regarding this. And also the processing of the language at the syntax level, at the semantic level, and at the pragmatic level. And then the next step, if the system understands the language, can process the language, then the system will be able to generate the language. Actually, I started with UI in Jakarta, some project regarding natural language understanding, but due to COVID-19, we actually couldn't continue, and there were many other things to do. So hopefully, when things goes back to normal, we will continue working on these projects. The second thing, which help us understand how we think using the technologies used in artificial intelligence, is deep learning. Okay, deep learning is a huge subject and is used extensively and intensively by Google and Facebook to recognize and categorize objects, words, and relationship by taking huge feature sets and learning to assess them. Despite the fact, the examples of the uses of deep learning are quite naive, how to distinguish between the photo of a cat and the photo of a dog, how to group people based on their facial features, etc., etc., etc. But deep learning is one of the advances that can become a breakthrough in the future in order to understand how we as a human think. And it uses the same way how we as a human think. So there are different layers of input nodes. These input nodes, neurons, send signal to a series of other internal layers of node, what is called the hidden layers, and other neurons in our brain. Each one of these neurons will send a signal to the next layer until the output layer is reached. And the output layer will be able to decide whether the image is the image of a cat or a dog. This can be applied to other application domains. Some of them are quite sophisticated, like the ones used by Google in their natural language processing, and in Facebook for deciding how to group people into different classes. So deep learning can be used in either the supervised mode or the unsupervised mode. No one node will do all the work the same way how our brains work, and the network as a whole will produce the result for any given input. Okay, and as I mentioned, the work on deep learning is inspired by the layering of computation that takes place in the cerebral cortex in the human brain. So it can give you some idea about how we, as a human, think. And this is just an example of how deep learning neural network work. Most of the research in artificial intelligence today is toward deep learning. A friend of mine, the author of the book, The Power of Predictive Analytics, the power to predict who will click, who will buy, who will die, who will lie, who will die. So is told me that, Ismail, if you look for the future of artificial intelligence, then it is predictive analytics. And the goal of predictive analytics is to find a relationship between a set of visible features, something we see in front of us, and the outcome. And it can be applied to different areas. It can be applied in marketing. It can be applied in politics. Predictive analytics predicted the winning of Barack Obama a few years ago. And it's used nowadays by most political parties in order to predict the outcome of the election. It is used intensively in healthcare. I have some health problems, and most of the recommendations for the medication I receive are based on some kind of a predictive model, because you cannot predict what, I mean, I am diabetic, so you cannot predict what will happen to a person with diabetes. And most of the time, the doctor needs to collect a huge amount of visible features regarding my health conditions in order to suggest the right course of medication for me, which is beyond the capacity of our minds. So it is delegated to a predictive analytic model, which will recommend. And of course, it can be used in many, many, many other application domains. So predictive analytics is the future of artificial intelligence. And there are different technologies used for predictive analytics. For example, regression analysis, which is to create a mathematical model that links the source of what you have seen and the target, what you will conclude or what you predict. A situation where only one single feature need to be tracked over time. In this case, we use the time series analysis, which allow the system to project a path of a feature into the future, given this base behavior, and also machine learning techniques like, for example, naive Bayes, with where individual features and then the predictive power are combined together to generate this single result, which is the prediction of what happened. So I only choose these three examples of a way to the use of artificial intelligence to predict how we humans think. Now let us go back to the Gartner multiple intelligences theory and how computers can succeed in any one of them. For I categorize them from high to moderate to low. Visual spatial. What is the field of what is called computer vision? Create models, create graphics, create charts, create photographs, drawing, the modeling of three-dimensional spaces, etc. Video, audio, multimedia, etc. We achieved moderate results in this type of intelligence as computer scientists. Now, bodily, athletic, we again achieved moderate to high results in this field. And you can trust the computer system in tasks related to this type of intelligence than before. Creative, unfortunately, no. You cannot make a computer an artist, a poet, or somebody who is able to do some creative work. Interpersonal, which means the relationship with others, this kind of social intelligence, we can say that the level of achievement we have made in computer science and artificial intelligence is low to moderate. Yes, through our smartphones, through audio, video conferences like this one, computers do much better than our face-to-face communication modes we used to in the past, but it is still a long way to go. Intrapersonal, zero. Computers cannot think about themselves. I mean, the far-reached dream of artificial intelligence is to create a model of thought. Linguistic, despite the fact you are impressed by the results of Google Translation, for example, or Bing Translation, Microsoft Translation, but it is still far below our human capabilities. I use actually Google Translate to translate from English to German and from German to English. Try to use some other complicated languages, for example, Chinese, Arabic, other difficult languages, and you will be quite disappointed. So we consider the level of advances in the field of linguistic is to be low. And the last, which is the highest, is the logical and mathematical.
Jadi sekarang tanya. Jadi komputer itu sekarang udah punya kecerdasan multiple intelligence sudah dalam komputer semua. Dari mulai telekonferensi, Google Translate.
Host, tolong dimatikan.
So, the logical mathematical, what computer achieved is much higher than what we humans are capable of. So this is conclude my talk. I always receive this question: what is the future of artificial intelligence? Artificial intelligence will not survive alone. Humans, as we know them nowadays, will not survive alone. We need a kind of collaboration between humans and computers. And this is what is called the mixed initiative system, a kind of computers that will not replace the intelligence of a human, but will augment, consolidate the intelligence of a human. I think I am done. Thank you very much. If you have any questions, I will be happy to answer them. And I am open if there are any proposals for cooperation with Indonesia. If you have any thing that you would like to do together with me personally or with my university, I will be happy to discuss it with you.
All right, noted.
Okay, so back to the MC. Thank you very much.
Thank you very much, Professor Ismail Khalil, PhD.
Thank you.
Ladies and gentlemen, it is now the time for questions and answer questions for our keynote speaker, Professor Ismail Khalil, PhD. And this question and answer session lasts from 15 minutes. And now, Professor, we have questions from the audience. The first one from Dani Eka Saputra. I attended a training on all before. In the training, they explain about strong and weak AI. They said that strong AI are not exist yet. No. Is it true? What is this example of a strong?
There is actually, I mean, I didn't discuss this. There are two campaigns. The first one is the optimistic. Can you hear me?
Yes,
Yes,
I
Prof.
can hear you.
Yes.
Do you hear me? So optimistic people who believe we will not reach the time of strong artificial intelligence, where computer will be able to replace humans. And there is also the pessimistic camp where people say that we will reach strong artificial intelligence in our lifetime. I mean, in the next 10, 15, 20 years, including, for example, the founder of Tesla and other people who are very, in my opinion, that if we fully understand the difference between human intelligence and artificial intelligence, we will not compete with each other. We will work parallel to each other to reach our mutual goals. So artificial intelligence will continue getting more and more advanced and sophisticated. Our human intelligence will continue to get more and more advanced and intelligence, but we will not try to compete with each other. We will always cooperate with each other. So strong AI, in the sense I defined in my slides, will not be reached, not in our lifetime, also maybe the next 2 or 3 generations lifetime. Did I answer your question, Dani? Okay.
One.
Thank you, Prof.
The other.
And yeah, Mr. Dani, so there is no competition in AI, yeah? Okay. I hope that Professor Ismail already answered your question. Okay, now we go on with the next question from Mr. Aang Kisnu Darmawan, Prof. And his question is, what is the basic differences of deep learning and quantum computing approach? Please, Prof.
In terms of technologies, they are totally different. They are two different things. Okay, in terms of technology, how to implement deep learning and how to implement quantum computing systems. In terms of goals, they both claim to be doing the things in more efficient and effective way. And you know, efficient means cost effectiveness. Would reduce the cost of computing and improve the performance of the system. In terms of technologies, they are totally different. In terms of objectives or goal, they are working toward the same goals.
Okay, thank you very much, Prof. So, Mr. Aang,
thank you.
I hope Professor Ismail already answered your questions. And
This is the last question, and thank you very much for Professor Ismail Khalil, PhD, for your presentation.
There is another question. I agree, Ismail. AI is not any better than human, but instead it helps each other to achieve better goals. So this is actually, I mean, if we don't work together, if we don't, research institute, industry, people, if we don't work together toward achieving this goal of which I call mixed initiated systems, where computer intelligence will augment the human intelligence, we will not reach this goal or achieve better goals, as you mentioned. Okay.
all right. Okay, noted, Prof. Thank you.
Thank you very much.
Thank you very much, Professor Ismail
Thank
Khalil,
you very much.
PhD. And this question and answer is already finished. And thank you for your participation.
Thank you very much. Assalamualaikum.
Thank you, Professor Ismail Khalil, PhD, for the question and answer session too. And Prof, would you like stay there on Zoom for a moment? Because the General Chair of APTIKOM would symbolically confer token appreciation. May we invite Professor Insinyur Zainal Arifin Hasibuan, MLS, PhD, to confer the token appreciation. Please, time is yours, Prof.
Okay. Hello, Professor Ismail.
Hi, Hasibuan.
Yeah, long time no see. Thank you very much for your time being a keynote speaker in our conference.
Thank you very much. Thank you. It's my pleasure.
Hopefully we can see you soon. And with that, I present this token of appreciation virtually to keynote speaker Prof. Ismail Khalil, PhD.
Thank you very much. Thank you. Much appreciated.
Thank you.
Thank you, Hasibuan.
Professor Insinyur Zainal Arifin Hasibuan, MLS, PhD, and Professor Ismail Khalil, PhD.
Thank you very much.
Ladies and gentlemen, we have still two more agendas. First, awarding Best Paper and Best Presenter and closing remarks. And now, it's time for us to announce and award the Best Paper and the Best Presenter in this international event. Dan pada kali ini juga akan ada pemberian penghargaan serta artikel terbaik dalam acara SEMNASTIK 2021. We would like to say congratulations for the best paper and the best presenter. To award the best paper and the best presenter, may we invite Professor Dr. Ahmad Nizar Hidayanto, SCOM, MCOM, as a professor in the Faculty of Computer Science in University of Indonesia. Professor Dr. Ahmad Nizar Hidayanto, SCOM, MCOM, please, time is yours.
Agus.
Ya, Pak.
Will be represented by Pak Usni ya. Pak from of today. From Nissan is off today.
Okay.
Will present by Pak Husni.
Siap. Oke, nasib. Husni.
For Prof. Husni.
Awarding. Husni, time is yours.
For Prof. Husni, time is yours.
Thank you very much. So I think this is that you waiting for. We not the best paper or so actually there will be 3 different categories for the best of this event. The first one is the best paper, and we will choose 3 papers as the best papers for this conference. And the second one is the best presenter, and we will choose 1 presenter as the best presenter. And the third one is the best paper from the SEMNASTIK. So I think it's not easy to announce this because you know that we receive more than 100 papers conference and SEMNASTIK, and after the review and after you present it. So I'm happy to announce the 3 best paper. The first one is the paper ID number 156. The author is Doni Setiawan, Betatya Wardoyo, Mohyubowo, and Elsa Hardiana Darwati. The title is Malaria Classification Using Convolutional Network Neural Network Review. Okay, congratulations, Prof. Yaya. The first best paper. Okay, the second one is the paper ID number 91. The author is Fabi Jametoni and Eka Putra. Title Study on Autonomous Drone Position Method. Okay, again, congratulations, Mr. Nadi. And the last one for the first category, which comes to the paper number 48. The author is Alvina Ramadhani, Edi Susoyo, and Vanda Pradiyasma Widarta. Title is LSTM Approach for Sentiment Analysis of Tourism Review on Beach in Trips Advisor. Congratulations, Alvina, for your achievement. Okay, so for the you guys have the best paper, so we have appreciation. The first you will get a certificate for the best paper, and the second one is you will get a free registration for the next ICIC 2022. And the third you will get the much of money from the committee from this event. This amount is 1 million IDR ya, Pak Yusuf ya? Rupiah, not dollar ya?
1 miliar rupiah.
1 million rupiah. So please send your bank account to the committee. Okay, so the second category will be given to the best presenter for the ICIC conference. So it will be given to the paper number 107. Okay, the author is Andreas Renaldi. Dharma Wijaya and Eri Prasetyo Wibowo. Prof. Eri. The title is Design and Simulation of Antipodal Vivaldi Antenna for 4G Communication Optimization. Okay, congratulations for the best presenter. So for the best presenter, will be given awards from the ICIC committee. The first one is we give the best presenter certificate, and the second one is we get the free registration for the next ICIC conference 2022. And the last one is I will give announcement for the best paper from the semantic for the SEMNASTIK APTIKOM 2021. So the best paper is given to paper ID number 7. The author is Grady Matias Octavian and Henry Santoso. The title is Leveraging MobileNet, Inception P3 and PropNet to Classify Cassava Plant Disease. Okay, so starting best paper again, you will get the paper certificates as a best paper, and again you will have the free registration for the SEMNASTIK or the ICIC conference for the next year. Again, congratulations for you guys for your achievement, and I give to Mr. ICIC. Thank you very much.
Thank you very much, and I would like to say congratulations for all the winners, and thank you for Dr. Husi Teja.
Ladies and gentlemen, distinguished guests, now for the closing remarks for the 6th ICIC 2021, may we invite the General Secretary of APTIKOM, Professor Dr. Renat Ahmad Beni Mutiara. Please, time is yours.
Thank you very much, the Honorable Chairman of APTIKOM, Professor Zainal Hasibuan, PhD, General Chair of ICIC 2021, Mr. Yusuf Durrahman, PhD, Rector of Nusa Mandiri University, Mrs. Dr. Dwiza Riana, Founder of Nusa Mandiri Indonesia Foundation, Mr. Herman Harsoyo, Chair of Nusa Mandiri Indonesian Foundation, Mr. Sigit Johari, keynote speaker, Professor Ismail Halil and Professor Teddy Surya Gunawan, session chair, and all presenter and participant of ICIC 2021 and SEMNASTIK 2021. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Peace for us all. Good afternoon, ladies and gentlemen. First of all, let us express our gratitude to Allah Subhanahu wa Ta'ala because thanks to His grace, we are still given healthy favor so that we can participate in the last session, namely the closing of ICIC 2021 and SEMNASTIK 2021. Distinguished guests and ladies and gentlemen, I'm very happy that this conference has gone well. There are 164 paper submission and only 82 papers are accepted, which is around 48% accepted rate only. This shows the highest quality of accepted paper. There are various topics from the accepted papers, and most of them are topic related to artificial intelligence application and development. And almost all presenters can attend and present their scientific paper, which are the result of research only. Ladies and gentlemen, all accepted papers are submitted to IEEE Explore with IEEE conference number 54025. And we hope that the paper that have been presented that can be accepted by IEEE to be published in the proceeding of the IEEE conference. And ladies and gentlemen, last but not least, on behalf of APTIKOM and ICIC committee, I would like to thank first Nusa Mandiri University as host, the second industry sponsor here LSP Informatika, the third the co-host Gunadarma University, Bina Insani University, Sari Mulia University Banjarmasin, Multidata University Palembang, Pasundan University, University Computer Indonesia, Bina Nusantara University, Budi Luhur University, Atma Luhur University, Raharja University, Microskill University, Stikom Bali Institute of Technology and Business, Parahyangan Catholic University, Potensi Utama University, Kelabat University, Dipa Makassar University, Dia Nusantara University, STEMIC Pringsewu, STEMIC Likmi, STEMIC PPI Tarakan, Stiki Malang, and Amikom Joka University for all support in organizing ICIC and SEMNASTIK at this time. Yeah? I personally also express my gratitude to the committee who has worked hard for this activity, as well as various parties that I cannot mention one by one. Ladies and gentlemen, for information, ICIC 2022 will be held tentatively in Bali, hopefully, yeah? And hopefully we could meet again at ICIC 2022. Ladies and gentlemen, the last, by saying Alhamdulillah, I officially close ICIC 2021 and SEMNASTIK 2021. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Sir Dr. Rernat Ahmad Beni Mutiara.
Ladies and gentlemen, we have the same attendance link of ICIC 2021 and SEMNASTIK APTIKOM 2021. Please, you may fill the attendance link. You can see on the screen. Okay. Now we have come to the end of the program. A great appreciation to all of you for having the pleasure of attending the entire event. Should there be inconvenient matters within the procession, please allow us to humble apologize. We wish you a very pleasant day and see you in the next ICIC 2022. Thank you. And wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Congratulations.
Congratulations.
Abdul Rahman.
Ya, sama-sama.
Sukses ya.
Alhamdulillah.
Ya.
Komite Profesor Dr. Husni Teja Sukmana.
Amin.
Alhamdulillah sehat.
Amin.
Okay, all participants. Thanks again. Hopefully we can meet again next year in Bali ya.
Bali, amin.
Ya, insya Allah.
Oke.
Atau mau di Riau, Prof?
Gimana?
Atau mau di Riau, Prof?
Lihat Maluhur juga boleh.
Riau nggak ada yang dilihat.
Ada juga kata mau ke Bangka katanya.
Ya.